Okay, so let's work on, let's say, another problem. What about, let's this one, do this.
We want to determine the dimensions of a rectangle bounded by the semicircle y equals the square root of 16 minus x squared that would maximize the area. So here's an example of what the rectangle might look like. Let's see if we can determine the dimensions of this rectangle. The length from here to here would be equal to y, but y is bounded by the function, so the length of this side here would be equal to the square root of 16 minus x squared. Now looking at the horizontal distance here, the distance from the origin to this corner would be x, and therefore the length on the other side would also be equal to x. So the length of this entire side would be 2x. So the dimensions for this rectangle are 2x by the square root of 16 minus x squared, which means the area of this rectangle would be the product of these two dimensions. So we'd have 2x times the square root of 16 minus x squared, which I'm going to write as the quantity 16 minus x squared to the 1/2 power. And we want to maximize this area, which means we'll have to determine the critical numbers of the function by determining where the derivative of this function is either equal to 0 or does not exist. And looking at this function, we'll have to apply the product rule in order to find the first derivative. So we'll let this equal.
Not very good problem. I think I like this one better.
A farmer finds that if she plants 50 trees per
Okay,
acre,
to pay attention to this, yeah, it's very important.
each tree A farmer finds that if she plants 50 trees per acre, each tree will yield 65 bushels of fruit. She estimates that for each additional tree planted per acre, the yield for each tree will decrease by 3 bushels. How many trees should she plant per acre to maximize her harvest? So the total harvest per acre is going to be equal to the number of trees times the number of bushels per tree. So if we let x equal the number of additional trees, we could say h of x, the harvest per acre, would be equal to the total number of trees, which would be 50 plus x, times the number of bushels per tree. Well, the bushels per tree start at 65, but it decreases by 3 bushels for every extra tree. So the total number of bushels per tree would be 65 minus 3x. So 50 plus x is the total number of trees, and 65 minus 3x is the total number of bushels per tree. Let's go ahead and multiply this out. H of x is equal to 50 times 65, that's 3,250. And then minus 50 times 3x, that's minus 150x, plus 65x, minus 3x squared. Let's go ahead and combine like terms and write the terms in descending order. We'd have h of x equals negative 3x squared. Combine the x terms would give us minus 85x, and then plus 3,250. So our goal here is to maximize this function. So for the next step, we'll determine the critical numbers, which is where the first derivative is equal to 0 or undefined. So h prime of x is equal to negative 6x minus 85, and then we'd have plus 0. Notice how the derivative function is a linear function, which is never undefined. So to find the critical number, we'll set this equal to 0 and solve for x. So we'll add 85 to both sides. Negative 6x equals 85. Divide both sides by negative 6. And we have x is approximately negative 14.17. And since x is a number of additional trees, we're going to round to the nearest whole number, so we'll use a critical number x equals negative 14. But we should still verify that the function is maximized, not minimized at this value. But we should recognize that the harvest function here is a quadratic function with a negative leading coefficient, so we have a parabola that opens down, or a concave down function. Therefore, this x value would maximize the function. But we can also use the first or second derivative test. Let's use the second derivative test to verify the concavity. So here's the first derivative function, and notice how the second derivative function, h double prime of x, would be equal to negative 6 Because the second derivative is always negative, the function is always concave down, which is good news because that means that our critical number, we have a maximum function value, and therefore the function is maximized at approximately x equals negative 14. But we might be thinking to ourselves, how can x be negative if x is the number of additional trees? Well, the total number of trees is 50 plus x, so the ideal number of trees would be 50 plus negative 14, or 36 trees per acre. So 50 trees is too many to maximize the harvest. So the harvest is maximized with 50 plus x trees, which is 50 plus negative 14, or 36 trees. I hope you found this helpful. Harvest function here.
Okay, any question on this problem?
None, teacher.
Do you understand about the problem at all? Imi comprende kung ano ba nina problem na kung ano ba sa ida, objektivo, tama sa mo kalkulas na ba niya, pergunta sa mo kung ano man ba? Okay. I want to ask Antonia, ne ka Antonia? Antonia niya ka Antonia? Ademia? Semen.
Antonia ya, teacher.
Teacher,
Okay, Antonia, explica to. Halta explicação como é kung ano problema ni. Kung komprehensahan ko na ba ito sa ida, what do you understand from this problem? Oh, Antonia. Try your best. Ademia? Iya ka Ademia.
iya teacher.
Can you explain to me what this problem is about, please? Uya tetong labot tida. Try your best. Labot ka tao sala ka los. Explica it ba kung komprehensahan ko na ba ito sa ida? Sa ida mo komprende ho si problema na ne. Explica to problema na meho.
Wait teacher.
O bel hari hela to, hakkya ka na ba mo so bel hela to?
Dia belele muy bien nia sentence baru si eu compreende.
Okay, sema bel explica. Sema bel comprende ho si problema ne. Agora how foi exame, how foi problema sa ne, mi la bel comprende na, di me to resolve el problema insa. Sema bel comprende problema ne. É voluntário não me hacker explica me how? Quando vai dinheiro ser compreensão quando vai né?
Um,
Go ahead. Just
Like-
try your best. What do you understand from this?
so
Okay, teacher.
Go ahead.
So this is
Kulit
this
tetong
problem
mos
that
dia
I get
inglês,
it.
option di inglês susah tetong mos laut tira.
Okay, dear. This problem that I get some point here about the calculus based on optimization problem. It's talk about the maximizing crop yield by deciding the best number of trees to plant per acre, teacher.
Okay, repeat that. Maximizing what?
Maximizing crop yield. Yeah.
Crop yield.
Yeah, crop yield.
By
Deciding the best number of tree plants per
acre.
acre.
Yes, very good. That is correct. So basically hanene ni dia na sane. Ia agrikultori da los gala. Niane hakarak katak nia atu kuda be ni por ejemplo ni kuda batar contohnya ya. Por ejemplo ni kuda batar ne ni hakarak katak ni toos ne kan ni be area ba toos ne constanta la muda da los gala. Ni total area ne la muda da. Mas be ni hakarak ya cada acre cada be kota-kota kikuang ne niya karak para saat niya panen nene niya panen ne karak maksimal yo. Então niya por exemplo asa cantareiro dessa por exemplo sa mi kuda moro nessa cantareiro kan cada cantareiro ida ne karak atau kuda moro hira para pada akhirnya ne one crop yield ne maximize gitu. Comprende to cantareiro ne saya to? Nema be volnaram be acre ne per acre. That's what it is, okay? So, banheira problema na sini acontece exame e me tem que compreender o problema se pelo me dá ya. Okay, what about this one?
You are a lifeguard and spot a drowning child 30 meters along the shore and 50 meters from the shore to the child. So if we look at the graph below, that means you would be at the origin, 0.0, and if we go 30 meters along the shore and 50 meters from the shore, the child would be here, where the ordered pair is 30, 50.
Okay, ini dia na sana ya. Sekarang ini serviço ia tasi ibong ya. Por exemplo, ia lahat ne timur ia kalay manega. Ia be kisure ia kalay. Por exemplo, ia malanya rain karek ia be lifeguard ne ema nebe serviço ia be tasi ibong babaeng ema. Nani ia tasi ne ia botruma acontece sira mahalay ba ajuda ema ne. Atene to? Atene to sa
Yes,
uma
teacher.
lifeguard ne. Nebe por exemplo na sana. Sekarang oma ka lifeguard. Por exemplo, oni posição inicial ne. Las galay. Por exemplo, o nota katak ia labarik ida ni ane be seda drowning katak be nani ba be ia be okostena label sa ia problema acontece 30 meter along the shore katak sekarik on the shore mane on the shoreline mane ni ane distancia usine bana 30 meter along the shore and 50 meters from the shore. Okay? 30 meter mai hane 50 meter ne hene banabane 50 meter. Husi o distancia mah hene 50 30 meter banabane 50 meter. That's what the child ini posisi exactly labarik ini posisi ne ba. O mah hene haka 30 meter ba limang karo e depois saba lurus ba 50 meter baleta. Ida ne posisi usa vector atau descreve labarik ini posição específico ya. Okay? Então, o tem que tem que halai husi da ne maka o halai te ne maka foi obele por exemplo onia roa ne para hene onia be roa ne para hene o tem que halai husi ponto zero ne ba ia te ponto mia ainda ne maka saiba para ba distância da na ba o tem que be nani ga ne gan san o halai te mane foi te onia alat pa nani ga halai te mane maka sai onia roa ga I don't know. But the problem is, you run along the shore, while the jump into the water and swim directly to the side. You can run at the rate on velocidade o halai husidane mahinene 40 meters per second and swim at the rate of 0.9 meters per second. In the rate of swimming nene, mane, how far along the shore should you run before jumping into the water? How long? Okay.
You run along the
Comprende todo ini problema ne. So how far along the shore should you run? Atau distansi dan ne halai mahenene tengki halai hira mak sebelum mo tengki hakat ba parato. Ne.
shore for a while and then jump into the water and swim from there directly to the child. You can run at a rate of 4 meters per second and swim at a rate of 0.9 meters per second. How far along the shore should you run before jumping into the water in order to save the child as quickly as possible? Round the answer to 2 decimal places. So going back to the graph, let's label the segment along the x-axis x. This should be the distance you run. And let's label this slanted segment y, the distance you would swim. We also need to form the right triangle here on the right. So let's go ahead and construct the two legs. We have a leg here, and we have a leg here. We know the long leg is 50 meters. And notice how the shorter leg would be 30 minus x meters. And now to solve this problem, we'll be using the distance equals rate times time formula. But because we're trying to minimize the time, we need to solve the equation for t by dividing both sides by r, which gives us time t is equal to distance divided by rate. And in our case, we're going to have the time t is equal to the run time plus the swim time. Let's let t equal t sub r plus t sub s. And now using the graph, let's go ahead and set this up. The total time t is equal to the run time. Well, the run time is equal to the run distance divided by the run rate, which is equal to x meters divided by 4 meters per second, giving us x divided by 4. And then plus the swim time is equal to y meters divided by the rate of 0.9 meters per second, which gives us y divided by 0.9. From here, we need to write t as a function of just one variable. We will write t in terms of x. Before we do this, though, notice how dividing by 9/10 is equivalent to multiplying by 10/9. So let's write this as t equals, let's write this as 1/4 x and then plus 10/9 y. And now let's work on writing y in terms of x using the right triangle. Well, we know from the Pythagorean theorem that 50 squared plus the square of 30 minus x must equal y squared, or y squared must equal 50 squared plus the square of 30 minus x. To solve for y, we take the square root of both sides of the equation, and because we know y is positive, we only need the principal square root, which gives us y is equal to the square root of the quantity 50 squared plus the square of 30 minus x. Let's also write this using a rational exponent and simplify 50 squared plus the square of 30 minus x. This gives us y equals the quantity x squared minus 60x plus 3,400 raised to the power of 1/2. Which means we can now write the time function as t equals 1/4 x plus 10/9 times the quantity x squared minus 60x plus 3,400 raised to the power of 1/2. In order to minimize the function now, the next step is to find the critical numbers, which is where the first derivative is equal to 0 or undefined. So now let's find t prime, which is the derivative of t with respect to x, which is equal to the derivative of 1/4 x, which is 1/4, and then we'd have plus 10/9 times the derivative of the quantity x squared minus 60x plus 3,400 raised to the power of 1/2, which is going to require the chain rule. So we have 1/2 times the quantity x squared minus 60x plus 3,400 raised to the power of 1/2 minus 1, which is negative 1/2, and then times the derivative of x squared minus 60x plus 3,400, which is 2x minus 60. And now we need to determine where t prime is equal to 0 or undefined, which is a pretty complicated process. So in this case, we're actually going to graph this derivative function to determine where it's equal to 0, which I've already done here. This is the graph of the derivative function shown below. Notice the derivative is equal to 0 at approximately 18.45, which is a critical number we need. Also notice how the derivative function changes from negative to positive when x is approximately 18.45, which means our time function changes from decreasing to increasing at the x value of approximately 18.45, which does verify we do have a relative minimum at this location. So if we set the derivative equal to 0, this gives us x is approximately 18.45, and this would be meters. And notice how this is the distance that you would run along the shore before jumping into the water to swim to rescue the child in order to minimize the rescue time. So as a complete sentence, you should run 18.45 meters along the shore before jumping in the water. I hope you found this helpful.
Debe, ini problema sir naman eh. So some of the problem in the application of